Hello guys, welcome back to another episode of Infinite Insight Geometry, Lesson 3.7, Triangle Proofs. Alright, let's begin. So, when we talk about triangle proofs are one of the foundations of geometry. If you don't know how to prove triangles congruent and then prove other things congruent based on those congruent triangles, then you're going to have a very hard time in geometry. And usually, these proofs come with a lot of ingenuity. You need to have creativity and imagination. Geometry is a part of math that requires another way of thinking. When you do algebra or calculus or trigonometry, you are doing stuff with numbers, you're doing calculations. But in geometry, it forces you to use a different part of your brain, the creative part of your brain. You're trying to figure out how to prove stuff using logic and not equations. So this episode is mostly focused on trying to bring out that creative part of the brain so that you guys can do geometric proofs. So I have two examples of triangle proofs here. And the first one is this. If angle B and angle C are congruent, and ray AD is an angle bisector of angle BAC, then prove that BD is congruent to BC. Alright, if you want to do it for yourself, I'll give you a moment. And here's the entire two-column proof. It's a bit simple, but we are mostly given pretty much everything that we need to solve the problem right there and then. All we have to do is to define some stuff, say that stuff is congruent, and use congruent parts of congruent triangles are congruent, CPCTC, to prove two sides congruent. So let's take an example. Angle B and angle C are congruent. So we know that those two are congruent. So ray AD is an angle bisector of BAC. Those are given. And angle BAD and angle CAD are congruent because that's the definition of angle bisector. It splits the angle into two, leaving two congruent smaller angles. That's why angle BAD and angle CAD are congruent. Now we have two angles and we want to find another piece of information that can help us prove these triangles congruent. So you have two angles. We could do it angle side angle, but that would require us to prove AB is congruent to AC. And that's not really practical because we are trying to find that these triangles are congruent. So maybe angle side can help us. Well, BD and DC are the other corresponding congruent sides, but we don't know that yet because that's what we're trying to prove. Meaning that the only other pairs of sides that we can use for angle side congruency is AD and AD. And this is where the creative part comes into play. Because, if you can see, AD is congruent to AD. AD is the same thing as AD. They are equal and congruent by the reflexive property of equality. Meaning that we can use the shared side, I'll call it a shared side, of these triangles to make them correspond and say that triangle ABD is congruent to triangle ACD by AAS congruency. So, now that we know that these two triangles are congruent, we can prove that angle B and angle C are congruent by congruent parts of congruent triangles are congruent. And that's our proof. Let's take another example. If angle E is congruent to angle J and EF is congruent to HJ, then prove that G is the midpoint of EJ and FH. I'll give you a moment. And here's the entire two-column proof. It's a bit longer than the first one, but it's nothing we haven't done before. Let's try and find definitions first. So angle E is congruent to angle J, and EJ is congruent to FH. Both of those are given. Now look at EJ and FH. They're intersecting lines, and they intersect at G. That's the definition of intersecting lines. So we know that when lines intersect, they form vertical angles. And the ones that we need to use right now are EGF and JGH, if you want to try and make those angles in your head, because those are the angles that we will want to use when we try and prove these triangles congruent, because they are part of the triangles. So we define them as vertical angles, and we use the vertical angles theorem to prove them congruent. Now, if you notice, we already have two angles and a non-included but corresponding side, meaning that we can already use AAS congruency to prove that triangle EFG is congruent to triangle JHG. Now that we've proved these two triangles congruent, now is the hard part. Now we have to prove that G is the midpoint of both EJ and FH. But since we know that EG equals GJ and FG equals GH, because they're both corresponding parts of congruent triangles, they are both congruent, meaning that they are both equal, meaning that we can use the segment addition postulate to say that EG plus GJ equals EJ, and FG plus GH equals FH. But since G is halfway between EJ and FH, that means that G is the midpoint of EJ and FH by the converse of the midpoint theorem, which is true. So we already proved that G is the midpoint of EJ and FH, which is what we were trying to prove. So there's our entire proof. So what I want you to take from this lesson is that geometry is a different part of math. It requires creativity and imagination. It's not like the other branches of math that you learn in high school, such as algebra or algebra 2. They're not like exponents or logarithms or functions. That's why many people struggle with geometry when they learn it firsthand, because it's not like the other branches of math. It's different. It requires you to have imagination and ingenuity, and that is what we're trying to provide insight for in this course, Infinite Insight Geometry. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I have my email down below if you have any questions, and I will see you all next time.